Hi everybody! Today we're going to be solving systems of equations using elimination. So in previous videos, we learned that a system of equations has two or more equations graphed on the same coordinate plane, and that the solution, what we're solving for, is the coordinate pair, or the xy, that the two equations have in common. So we're going to look at how to solve the system of equations using elimination. So the two things we need to know in order to solve systems of equations using elimination is that the equations need to be in standard form, or ax plus by equals c. We also can only use elimination when at least one pair of the coefficients are equal. So they need to have at least one pair of equal coefficients. So that means that either the coefficients of x need to both be the same number, or the coefficients of y need to both be the same number. So we're going to look at a few different examples. We'll show when we add for elimination, when we subtract for elimination, and then we multiply for elimination. Let's get started. So we are going to add to solve this system of equations when the coefficients that are the same have opposite signs. So for example, 2x plus 3y equals 13 and negative 2x plus 8y equals 20. Well, x's have the same coefficient. One is positive, one is negative. So we are going to add these equations together. So 2x plus 3y equals 13. We are adding to negative 2x plus 8y equals 20. When I add these equations together, we're literally adding them vertically. 2x plus negative 2x is 0x. 3y plus 8y is 11y. And 13 plus 20 is 33. We'll now solve for y by dividing both sides by 11, both sides of the equal sign by 11, and we end up with y equals 3. Once I have one variable, I'm going to choose either equation to substitute it back into and solve for the other variable. So here y equals 3, I chose to substitute it back into this first equation. 2x plus 3y equals 13. So 2x plus 3 times 3 equals 13. 2x plus 9 equals 13. Subtract 9 on both sides of the equal sign. That leaves me with 2x equals 4. I'll divide by 2 on both sides of my equal sign. Oh, delete. And x equals 2. So the solution to this system of equations is x equals 2, y equals 3. Because the coefficients have opposite signs, we added the equations together that eliminated our x's. We were able to solve for y, substitute it back in, and then solve for x. Let's look next at when we are going to subtract. So we are going to subtract when the coefficients have the same signs. So here, 2x plus 3y equals 10 and 4x plus 3y equals 20. Both y's have a coefficient of 3. Both are positive, so they have the same sign, which means we are going to subtract the two equations. So 2x plus 3y equals 10 minus 4x plus 3y equals 20. This means we're going to subtract our x's, our y's, and our constants. So 2x minus 4x is negative 2x. 3y minus 3y is 0, so we subtract out our y's. And 10 minus 20 is negative 10. Now I'm going to divide both sides of my equal sign by negative 2, and I end up with x equals 5. Once I have solved for my x, I'm going to substitute it back into either of my equations to solve for y. So I chose the first equation, 2x plus 3y equals 10, and I substituted in x equals 5. So 2 times 5 plus 3y equals 10. 10 plus 3y equals 10. Subtract 10 on both sides of the equal sign. That leaves me with 3y equals 0. We can divide by 3 on both sides of the equal sign, and y equals 0. So my final solution to this equation is 5, 0. The coordinate 5, 0 is the xy ordered pair that both of these equations share or have in common. For our final example, we are going to multiply. We only multiply when the coefficients need to be matched. So if the coefficients of one variable are not the same, we can multiply and make them the same. So in this example, I have 3x minus 2y equals negative 7. and 2x minus 5y equals 10. Well, these do not have any matching coefficients, so I'm going to fix this by multiplying both equations. So I'm going to multiply my entire top equation by 2 and my entire bottom equation by 3. That will result in me having 6x and 6x, which would match both of my x coefficients. So I'm multiplying the entire top equation by 2, the entire bottom equation by 3, and that leaves me with 6x minus 4y equals negative 14, and 6x minus 15y equals 30. So now I have matching coefficients. Because they're both positive, I'm going to subtract my equations. So 6x minus 6x is 0x. We subtracted out our x's. Negative 4y minus negative 15y is 11y. And negative 14 minus 30 is negative 44. We'll divide both sides by 11, and y equals negative 4. Now I can choose any of these equations to substitute in this y equals negative 4. I could choose this first one, this second one, or the ones that were multiplied. I chose the first one because it's typically easiest. Oh, that's a lie. I chose this one, 6x minus 4y equals negative 14. Just goes to show that you can choose any of those 4 equations. I substituted in y equals negative 4 for y. That gives me 6x plus 16 equals negative 14. I subtracted 16 on both sides of my equal sign. That gives me 6x equals negative 30. Divide by 6 on both sides of my equal sign, and x equals negative 5. So my final solution is negative 5, negative 4. So in this video, we talked about our final way to solve systems of equations using elimination. This is the best method when the equations are in standard form. We are going to add when the coefficients have opposite signs, subtract when the coefficients have the same sign, and multiply when the coefficients need to be matched. Thanks for watching. I hope this video was helpful. Make sure to subscribe so you never miss a video, and I'll see you next time.